Greetings to everyone. Today we are going to learn about the reagent lithium dialkyl cuprate. Lithium dialkyl cuprate is otherwise known as lithium dialkyl copper or otherwise it is commonly called as Gilman reagent. It is a versatile reagent to effect C-C bond formation. That is, it is used in the reaction of C-C bond formation, and it is a lithium and copper reagent compound, and it is represented as R2CuLi, where R is an alkyl or aryl. These reagents are useful because, unlike related Grignard reagents and organolithium reagents, they react with organic halides to replace the halide group with an R group. Such displacement reactions allow for the synthesis of complex products for simple building blocks. Preparation. Gilman reagent is one of the most popular organocopper compounds discovered by Henry Gilman and co-workers. It is prepared by transmetallation of alkyl lithium compounds, that is, 2 moles of alkyl lithium is treated with copper bromide in the presence of diethyl ether, and the temperature is maintained at minus 70 degrees centigrade, and it forms lithium dialkyl cuprate along with lithium bromide. The alkyl lithium is obtained by the reaction between alkyl halide and lithium metal. This 2 moles of lithium is treated with alkyl halide and it forms alkyl lithium along with lithium halide, where R in Rx may be methyl, primary or secondary alkyl, cycloalkyl, vinyl, allyl, propagyl and aryl. This reagent is less stable and therefore usually prepared in situ. Applications. Now we can see the applications of lithium dialkyl cuprate. It is used in the synthesis of hydrocarbons. Lithium dialkyl cuprate reacts with alkyl or aryl halides or tosylate to yield hydrocarbons. The preparation of hydrocarbons using lithium dialkyl cuprate and alkyl aryl halide is known as Corey-Posner-Whiteside synthesis. The alkyl aryl group in organocuprates are nucleophilic in nature and are able to displace the halide ion tosylate from primary, secondary and aryl halides or tosylates to give hydrocarbons. Since lithium dialkyl copper itself is formed from an alkyl halide and react with another molecule of the same or different alkyl halide, the net effect is coupling of 2 alkyl halide as in the Woods reaction. Now this is the reaction showing the formation of hydrocarbon, where an alkyl bromide is treated with lithium and it forms alkyl lithium. Again it is treated with copper iodide and it forms lithium dialkyl cuprate. Along with this it is treated with another alkyl halide and it forms the hydrocarbon. The same type of reaction is depicted here with using different alkyl halides, and it shows the formation of hydrocarbons. The next type of reaction is the reaction to vinyl halide is stereospecific with the retention of configuration. That is, the configuration is retented. A vinyl halide is treated with lithium dialkyl cuprate and it forms the vinylic compound. The next type of reaction is many gem dihalides do not react, but when the halogens are on an alpha carbon to the ring or on a cyclopropane ring, both the halogens can be replaced by alkyl group. Here the reaction is depicted having gem dialkyl group that is treated with lithium dialkyl cuprate and it is replaced by the alkyl group. These are the series of reaction that is showing the formation of alkylation, that is formation of hydrocarbon reactions. This method of synthesis of hydrocarbon is more advantageous than other methods because of the following reason. The cross coupling between 2 different alkyl halide also give high yield of the required alkane. As R2CuLi is a very weak reagent, alkyl halides do not undergo elimination reaction. This is generally a side reaction in other methods. Coupling is also possible with less reactive halides such as vinyl and aryl halides. Next, it is used in the synthesis of alcohols, that is Reactions with epoxides. Epoxides are converted into alcohols on reactions with lithium dialkyl cuprates. The alkyl carbanion from the later attacks the less substituted carbon to give more substituted alcohols, and the reaction is depicted here. Another reaction is reactions with aldehydes and ketones. Organocuprates reacts readily with aldehyde to give secondary alcohol. Example, benzaldehyde on reaction with lithium dimethyl cuprate gives phenylethanol. And the reaction of lithium dimethyl cuprate with 2-methylbutanol, a chiral aldehyde, gives the alcohol diastereous selectively. Lithium dialkyl cuprate reacts with ketones very slowly under normal condition. However, the reaction takes place readily in the presence of chlorotrimethylsilane to give the silyl ether that can be hydrolyzed to the corresponding alcohol. The reaction is depicted here. That is, the carbonyl compound is treated with lithium dialkyl cuprate in the presence of silyl chloride, and it gives the corresponding alcohol. The third type of reaction is synthesis of ketones. In this substitution, the ketones can be synthesized by reactions with acid chlorides. Acid chlorides reacts with lithium dialkyl cuprate to form ketones. The advantages of the reactions are: further reactions of ketones with lithium dialkyl cuprate to become alcohol does not take place. But Grignard reagent reacts with initially formed carbonyl compound to yield tertiary alcohols. Organocopper reagents, being less reactive than Grignard reagent or organolithium compounds, do not react with functional groups such as nitrocyanocarbonyl and ester. So the desired compounds can be obtained easily. The next with reactions with alkyl thioesters. Gilman reagent also reacts with thioesters to form ketones. Reactions with alpha-beta unsaturated carbonyl compounds. Gilman reagent add to the alpha-beta unsaturated aldehydes and ketones to give exclusively the 1,4 addition product in a reaction closely related to the Michael addition. Organocopper reagents are soft nucleophiles and therefore attack at the soft electrophilic center of the alpha-beta unsaturated ketone, that is the beta carbon. In contrast, Grignard reagents and organolithium reagents are hard nucleophiles and they attack at hard nucleophilic center, that is carbonyl oxygen, to yield mainly 1,2 addition products. These are the reactions shown here. That is, the first reaction shows the alkylation one, the second with formation of unsaturated carbonyl compound. The next one, alkylation of amines. Primary and secondary amines reacts with organocuprates to form tertiary amines. Thank you.